My name is Paul Ebersman. I work at Infoblox as an IPv6 evangelist. And so what I'm talking about today is there are a lot of habits that we've had over the years dealing with IPv4 networks that are actually going to be impediments in v6. And I'll try and talk about some of the things that have changed in v6 that may let you rethink how you are doing some of your networking. I do apologize in advance. I'm going to be blowing through the slides a little fast. This is actually a little more material than the time slot, but the slides are available, and please do hit me up with questions afterwards if we run over into break. So there have been, as you've probably noticed, quite a few changes with IPv4 to IPv6. In theory, it's a good thing. There are a lot of problems with v4 that have been fixed, but the scope of the problem and the change is even broader than the days we went from classful routing to CIDR. It's probably more in scope of how much fun we had and time frames for rollout for doing Y2K. My guess is we have a couple of years of dealing with IETF issues to actually get this up and on our networks usefully. Start with some of the good news. There were a number of changes that do allow routing to be much more efficient. Headers are fixed size. There is now an extension chain, and router-relevant packets are at the beginning of the header chain, so you can parse, hit the first non-relevant, and stop. There are flow labels actually more usefully put in. Intermediate boxes no longer fragment and defragment packets, which is a really good thing in some ways. And they finally decided that the IP checksum was not terribly useful since there were checksums above and below it. All of those together mean that ultimately when we get to the point where we have routers that are actually doing v6 in our core only and don't have to accommodate v4 packets at the core level, we will actually be able to shovel packets at a better rate, and at least if you control all of your routing domain, might have something resembling the mythical QoS. Still, inner domain is going to be pretty much broken, but at least we'll have pieces of it more usefully than we have in the past. There will also be some efficiencies on our individual subnets. Moving away from broadcast to a multicast where you send from one sender to a group of entities that have registered to provide services like routing, DNS, DHCP, and the way that we have replaced ARP with solicited node, and some of the improvements that have been made with more specific message types in ICMPv6 mean that, again, once we get v4 off of a particular subnet, we'll actually be able to get more hosts within that broadcast domain without broadcast equivalent traffic clogging things. Not quantum leaps, we're not going to be able to get the 18 quintillion possible hosts that a 64 has, but we might get 20 or 30% more hosts on for the same traffic pattern than we're getting now. One of the other things I love with this is that for years now we have dealt with the address ranges that we have begged, borrowed, stolen, and used private addresses. We have cobbled together things as best we could with duct tape and baling wire. With IPv6, at least with Greenfield, or if we're doing a new overlay, we actually do what our job description says, which is get to architect networks again. One of the big things, obviously, is you can't actually get enough space to have a sane, logical, self-documenting subnetting scheme. One of the things I recommend heavily, use global unicast or GUA address space, publicly routable, guaranteed unique space for everything. Even if you are using 1918 and you are planning on not letting it out to the internet, get the GUA space sufficient for replacing all of that, and I still recommend using that and firewalling it. It means you have the choice. If you then decide you want to have access to the internet for those networks, you don't have to renumber. And even if you keep it segregated from the public internet, if you are combining networks or mergers, acquisitions, department shifts, and you're using private space that's not guaranteed to be unique, you usually wind up renumbering. If you use GUA everywhere, you will know that it's unique and you won't have to renumber. Figure out how you're dividing up your user populations, your provisioning, your budgeting authority, your security zones, whatever it is that you divide all of your people out, use that as your model, because that's how you think about your network and your users. Do your subnetting to map exactly to that. I've got a sample scheme that shows what you can do for a data center that's geographically distributed with no backbone, just to get you an idea of how to think about it. You're going to need to do it for what works for you. The other advantage of doing it that way is usually your ACLs are exactly based on those budgeting or security zones, and if your subnets match those, you have single subnets for your ACLs, and it's a lot cleaner. There are some things that These are general numbers that you're going to need in your planning. Pretty much right now, 48s are the size that people will announce. They will not announce longer prefixes. Yes? There's a question in the back?
Sorry, unless you're a Brookhaven house in the 127.
Just hang on a second, Joe.
Yeah.
Yeah, sorry, I was going to say quickly, unless you're a Brocade house and you try and use a 127 in IPv6, which doesn't work, you have to use a 126.
Yeah, it's a bug. Let me get down to that point. The general thing is 64s for subnets. Anything that has an actual host on it, you should use a 64. Reason being that Slack uses the 64 rightmost bits for the host ID, and unfortunately I have already seen of enough pieces of vendor gear that therefore hard-coded 64 bits. Operationally, you should stick to that for your subnet hosts. Anything that is routing or switching gear, if it can't take longer subnets all the way down to 127s correctly, it's a bug, file it. The reason that you use 127s for point-to-points is that's the only way to guarantee that you are not susceptible to ping-pong attacks that can melt the link with traffic. 126 still allows you to do ping-pong attacks. So there are people who say use 64 for everything, including your point-to-points. If you like that provisioning, my recommendation is fine, provision it, but when you actually do your routers, take only a 127 out of that 64. That way you get the provisioning consistency with the address waste if that bothers you or not, but at least you're having the security thing. Read the RFC for more. 128s are pretty much the equivalent. Any place you're putting a 32 now in your routers for v4, you'll use a 128 instead. If you are using the recommendation I have where you use 127s for point-to-points, 128 for loopbacks, what I would normally do is use a 64 for each of those per routing domain. Obviously, if you have two disconnected networks, don't use a 64 across both. The nice thing is that that's another one. If you have all of your loopbacks for all of your routers in 164, you put that ACL in from your NOC. They all have SSH access in with one single ACL. Here's the sample plan. I won't go into detail. The key point here is, just like in IPv4, 8-bit subnet boundaries are easy because you're not dividing the number in between the dots. And it's easy and you don't have to think about it. In IPv6, every one of those 32 hexadecimal characters in the address is 4 bits or a nibble. If you do everything in prefix lengths that are divisible by 4, you will never divide in the middle of one of those. We have enough address space for now. Make it readable, make it self-documenting. If you have questions about this later, please get back to me. Another big change in our mental picture is, when we go to the RIRs, in the old days, I got a Class B by saying I have more than 256 hosts, and you were done. Even though we can't get that kind of space anymore, RIRs for v4 will tend to think in terms of hosts, and we will think in terms of hosts, because address space has been scarce. With v6, at the RIRs, in your planning every place else, we have 18 quintillion possible addresses in any 64. You will never use them up usefully. So subnetting is actually where you need to start thinking and planning. Another one, brute force scans. One of the things that everyone says about v6 is that it's much more secure because you can't brute force scan. That's true, but not if you match your v4 and your v6 addresses for consistency. Makes it nice and readable, but you pretty much have reduced 18 quintillion down to 256, and that's brute force scannable. There's plenty of address space. Go ahead and use it all, and if in most cases you will probably be using DHCP for end client anyway, that will randomize. If you have a subnet where Slack seems appropriate, it will also semi-randomize as much as MAC addresses are random. 1918 and NAT. I have certain strongly held opinions. Sadly, yes, it did make sense for a while, though it probably put off IPv6 deployment by at least 10 years because the IETF said, oh, no, NAT won't work, we have to upgrade. Oh, wait, here's NAT. Oh, it solved your problem. Oops. IPv6 wasn't really there. Everyone was desperate. Possible hallucinogenic substances. I really don't know what finally drove the IETF to do NAT. We have been living with it ever since. And of course, why is it still around? Because most people are using 1918 space in all sorts of places as the way to get by. Is there anybody here who has no 1918 anywhere in their networks? bravo, and this is more than I usually see. NAT is not really secure. That is one of the other lovely myths. I use NAT because it's an additional layer of security. No. The public address to many addresses behind it, which could be public, not private, does indeed make it more difficult to get to individual clients. A stateful firewall will do exactly that. The address translation from public to private is what NAT is. And if you don't have private addresses, you don't need to worry. The other thing is that we have basically killed an entire generation of interesting products and really bent and twisted other things like Skype to deal with NAT. If we had true end-to-end connectivity, there are any number of things that will really, I think, in the way of interesting products, things that we can come up with, other people can come up with. It's really not there. I mean, stateful firewall is there. That will deal with it. But it makes debugging much more difficult. It makes end-to-end break. There's really no good thing. Yes?
I have a big issue about people with the IP6 who say that the NAT doesn't bring any security. I have a big issue with people saying that the NAT doesn't bring any security. I agree that it's not a perfect security mechanism, but what it is completely required. A user can't turn off their NAT at home and then still route out to the internet. What will happen with IP6 is people will have some sort of routing problem with their firewall. They'll turn the firewall off and suddenly the network is completely unprotected. So you'll end up, for lots and lots of areas, being less protected than we're in the NAT situation. Although, NAT's not perfect, it's not a perfect firewall, but it's something that is required. And they don't have any choice. Just a thought.
Well, actually, you're saying not that NAT is the thing. You're saying that private address space is the secure part, the additional security in that argument.
Oh, yes, yeah, but
yes.
They go hand in hand. I.e., everyone's using 192.1.0.68.
I would like to decouple that. That's my point. Use of private address space has, in certain situations, use or utility. Stateful firewall has, in certain places, utility. But the reason that people used NAT and started saying NAT is more secure is we were making ourselves feel better. We had to use it because we were using private address space and we couldn't get public address space. So we tried to say, well, it really sucks and it has all this stuff, but, well, it's kind of more secure, and we made ourselves feel better. What I'm stressing is don't get hung up on that with v4. Actually make informed choices of whether or not private address space is a better technical choice or security choice. Make a decision whether stateful firewall buys you enough security for the additional logging and performance issues and potential DDoS problems that you have with it being clogged. So I'm not saying that it's all wrong. I'm trying to break out the definitions. So moving on. The other thing is, as much as I say NAT is evil and we should try and avoid it wherever possible, I have a beer bet that there are people out there, because I know of military institutions in the US who have this. They have a security checklist, and it says, do you use NAT and private addresses on your network? And if you fail to check the yes box, you fail your security audit. There is no, does it make sense, is there a better substitute, little asterisk, or do you do this? It's, do you have NAT, do you have private addresses? We will have people who will be waiving large checks, and vendors will write NAT success even if the IETF doesn't do it. So, but, again, the key here is use it when it makes sense. Don't make yourself suffer if you don't need to do it or if there's a better technical solution. Lack of address space is no longer something we're stuck with, so we have more choices. And MAC addresses. This is going to be an issue for all of us. So the IETF said, gee, MAC addresses are broken and evil and inherently flawed because they're not really unique. Vendors sometimes reuse them on cheap cards. You can alter them in software. And if you have a box that has multiple interfaces, the first one that DHCPs will win, other interfaces using the same MAC address will be told you already have a lease, go away. All that's true. But the overwhelming evidence that the IETF has ignored is that 99.9% of the entire internet actually gets on with DHCP using MAC addresses, and the internet hasn't fallen over. So obviously, while it's not perfect, it seems to work pretty damn well. And most people are already using it, and that's how they do their provisioning. But they decided what they would do is do the DHCP unique identifier. And it does have some good points. There is one per host, either server or client. And every single network interface has an identity association or IA. That pairing of DUID and IA means that that's a unique key that you can use with DHCP, so every interface can use DHCPv6 and get its own sets of addresses, and it will actually work. That's the upside. And you can do it for temporary or privacy addresses, you can do it for regular addresses, ULA or DUA, or you can use it for delegating entire prefixes. Well, there are some other issues, unfortunately. If you are already using Mac filtering, well, you can still do that for a while with v4, and v6 uses the same MAC address, and usually the switch does it by MAC. But if you are moving to v6 only, you can't get that information. There's no way of going through the lease files and saying this particular entity has this set of v4 and this v6 address set. For people who are doing IP address management, logging, auditing, that's going to be an issue. And persistent storage can be unexpected. The first time that you DHCP as a client or start up as a server, you check in your persistent storage on your disk to see if you have a DUID. If you do not, you generate one. You then write it. For ISC-based, you write it in the lease file on the client or the server. On Windows-based, you write it into the registry. Fine, that's cool, and the next time you come up, it works. If you change network hardware and MAC addresses, it doesn't matter because it's on your hard disk. That's all good. But I'm the IT department. I get a new engineering laptop. I set it up with all the software the company wants. I set it up with a VPN. I do everything. I make it all good. I check that DHCP works. Then I start ghosting that disk to 12 other laptops. And I forgot to wipe the registry. I now have the duplicate MAC address problem. So they have their own methods. Now, since it is disk storage, and I duplicate disks, there's no guarantee that my DUID is unique. And obviously, since I write it to disk and it writes to the registry and I can use regedit, or it's in the lease file and I can use VI on it, I can alter it. So, sound vaguely familiar like the problems with the MAC address? Much more fun, much more complex. There are some things also with dual stack. They are trying to fix this in the IETF. There is a draft that is looking much more hopeful to put the hardware address or MAC address into relays, which most larger institutions will use rather than having the DHCP server on the same actual subnet as the clients. And that looks like it will pass. If you are using the option 82 stuff, circuit ID, remote ID, currently for your provisioning and filtering rather than MAC address, that actually works in v6. So that may not hit you. But something you need to think of, if you care about MAC address and clients, that's going to be an issue. Do you do DHCP? v4 was easy. You statically configured or you statically set the host to use DHCP as soon as it came up. IPv6, more choices. You can still statically configure, which I would recommend for all router switches, networking gear, and large and important servers. There is what's called stateless auto configuration, or SLAC, where the host actually configures its own address based on information it gets on its own local subnet. There's what's called stateless DHCP, which is where you generate your own addresses, but you use DHCP for things like DNS server, NTP, etc. And then there's the full DHCP experience. Now, SLAC uses what are called router advertisement messages. That means that the routers on the subnet that you're on sent out messages with your network information and policy. What that means is instead of getting all of your information from the DHCP servers, which tend to be fairly centralized, you've now moved this all the way out to your edges to every single subnet you have. One thing you need to start thinking about is that means that when you're doing security and network audits, you aren't just looking at your DHCP configuration anymore. You are looking at that, but you are now also auditing every single router and every single switch port everywhere on your network. So you've probably gone from a few to a dozen DHCP servers to check to possibly hundreds or thousands of interfaces that you now need to vet. Also, RA messages have some interesting stuff in them, like default routers and which prefixes and whether you should DHCP or not. One of the things they don't have, or didn't for quite a while, was a DNS server. They decided that that was bad. They added that with this RFC last year. Unfortunately, client support is spotty. which means that for you, if you have a homogeneous network with lots of different vendors floating around, you must still use DHCP to make sure that everybody gets DNS servers. DHCP can do all sorts of interesting things. It can give you public or private addresses. It can give you prefixes. It can give you all of the other stuff that we have come to know and love with those funny little boxes. Printers, phones, all the other things that have all of that vendor goo buried in the options. It can give you DNS. It can update DNS if you want it to, rather than having your clients do it. It doesn't give you a default route anymore. So you can't have DHCP without having an RA announcement saying you should DHCP. So to some degree, the whole Slack or DHCP is a specious argument, because Slack people will still have to have a DHCP server for at least RDNS, and DHCP people will not be able to get by because clients won't DHCP, nor will you get a default route with RAs. So both are there. What it really boils down to for you are the choices. Are you doing some kind of filter or access control as a way of doing DHCP? Are you using your server as one of the means to get things into some kind of IP address management system? Are you doing DDNS updates for A, Quad A, and pointer records in DNS that way? Do you have a more centralized model? Do you have things other than simple things like tablets, phones, laptops? Things that require a lot of vendor options. If you need any of those things, the odds are that Slack will not solve your problem. On the other hand, I think where we're going to see Slack in use is places that either like coffee houses where they literally don't care and they have a very simple environment, or in embedded devices, because Slack is a much easier piece of code to write in a tiny piece of Flash than a DHCPv6 client. And if you have a decentralized model, if you use Slack completely, you really do only depend on that subnet. So if that subnet has internet connectivity but can't get back to your central facilities or some of your servers, much less impact than if you were in a DHCP environment. But if you need logging, if you want to be able to do DNS updates in a secure fashion, if you have any kind of IP address management, you probably won't want to use Slack for those things, because you're going to essentially have to troll through your network by hand, go through neighbor cache tables and all sorts of other things to figure out what addresses people picked, because there's no protocol that says after I've done Slack to tell anybody else what address I have. So look at your priorities. Another one that is probably very valid for a lot of people is, what is the level of your technical staff? In a coffee house, 0. You know, you can probably get them to flick the power switch on the right box most of the time. That's going to affect things. If you are supporting a very wide range of gear, again, that's going to probably push you to DHCP. Really quickly on prefix delegation, essentially what this is instead of getting an address, I can actually be given an entire prefix. So I can be given a /56. I can then actually turn right around and act as a DHCP server to devices subordinate to me and give them 60s or 64s. So vendor support is light, but it's happening. A lot of the CPE folks are finally getting it in because people like Comcast are pushing them to provide it. Comcast is a US broadband provider with 30 million users who is actually trying to roll out prefix delegation and IPv6 to the home. Potentially really cool stuff once it's there. ICMP is another one. If you are filtering ICMP right now and you say, well, gee, I don't really care about the few things that v4 ICMP does. Yes, it makes things more difficult for my network operations center, but it's way more secure. You can get away with that in v4 and your network will not break, even though it may not be fun to run. If you don't have ICMPv6, the right kinds of messages enabled, you won't be able to detect duplicate hosts. You won't be able to find routers, get prefixes, get default routes, know if you should DHCP or not. PathMTU discovery in v6 breaks because you have to get an ICMP message back saying somebody dropped the packet. And it's nice to be able to have echo requests and actually debug your network and see network errors. All of those things require v6. The plus side of ICMPv6 is they have made those messages much more precise and specific. So yes, you can filter what you don't want, but leave the stuff that actually is required for your network. See Adrian in the back.
Yeah, you might be alarmed to hear that people are already filtering ICMPv6. As an ISP, we currently have a sort of TCP fix-up to fix MTUs on TCP SYN packets for IP4. And we thought we don't need to do this for IP6. Unfortunately, customers found cases where web servers and the like were filtering ICMPv6, stopping the too big error, and we've had to put TCP MTU fixes in our broadband lines for this, unfortunately.
It does not at all shock me. I have found that there is somebody that will do almost anything stupid and catastrophic, frequently put it into a cheap box and sell it. My response to that is that you point them firmly at RFC 4290 and tell them to read it. The problem is the kind of people that do that don't know what an RFC or the IETF is. Usually then you're reduced to being that, oh, that customer again.
Can I just request that we park the questions to the end of Paul's talk because we're overrunning into the coffee break at the moment.
Yeah. So this is the RFC that people should read. It has excellent recommendations operationally. You should be familiar with it as well. And then the last bit on this, PDR records. You can read the history later, or I can tell you war stories of how it truly started way back in the dark ages when ftp.uu.net was actually a significant portion of data available on the internet. It was a bad idea then, but we were lazy and annoyed. It migrated to all sorts of other places that were even less sane uses of it. And unfortunately these days there are all sorts of security software, certain websites, people, unfortunately, like last I checked, New York Times and others who actually care. So if you truly don't do it, unfortunately there will be some user calls. As much as I personally would just love us to say, it was stupid, it was a bad idea, let's walk on, that's not really an option. Before, there are an awful lot of ways that you could actually pre-populate or deal with all of the IPv4 pointers, because you only got 256 and a /24. Scale was there. 18 quintillion of these for a single 64, and then there are 34 labels in the file and figure 60 to 80 bytes per record times 18 quintillion, and you know, petabytes of petabytes of petabytes of disk or RAM to hold this zone file for one subnet. Pre-population is definitely not it. So, unfortunately, the first option, admit it was a bad idea, not going to happen. Pre-populate, not going to happen. What I expect to see is that in the same way I recommend static routing for routers, big servers, significant things that are important and don't change much, we will probably be hand configuring or using whatever tool we're using, doing the forward and reverse for those entities as well. Then what I'm expecting is for people who care in other places, most of them have users that actually have some expectation that when they scream that someone will do something, are also doing DHCP. So using the DHCP server to add those pointer records is probably the most sane thing out there. I have heard people requesting, and I suspect that at some point vendors will start doing essentially lying on the fly. You can't really do a wildcard because you have to wildcard every one of those nibbles, which are one of the 34 labels in the 32 nibbles.ip6.arpa label, which is insane and doesn't work very well or as expected. So in most cases, people don't actually match the quad A and the pointer to see if they're actually the same. They just check to see if both exist. And so there will be things where essentially you lie on the fly and it says, is it my address range at all? If so, I'm allowed to tell you, sure, I've got a PTR record, here it is. That's going to be cool unless you're doing DNSSEC, because DNSSEC is basically designed to exactly to break things like this. The only way around this is the Akamai trick where you actually put the secret key on and sign them on the fly, which is kind of scary security-wise and computationally expensive on your servers. So, last bit, IPv6 isn't there yet. There are approximately 200 RFCs current and actually not obsolesced for IPv6, DHCPv6, and all of the related stuff. There are well over 200, actually these days closer to 250 drafts in active edit in the IETF. And they are adding more all the time, and it's not going down. So we are not yet there. And operational input of real users with real customers has been scarce because the IETF has not been overly solicitous. What I recommend, we all have problems. The IETF is not coming up with solutions. One of my jobs, I go to every IETF and I participate on the working groups because we have a vested interest. All of you have a vested interest. Even if you can't travel there, get on the working group, post, participate. You can't whine if you don't go in. The other is, there are a lot of problems. Pick the biggest, nastiest pile of cruft first because we have too much stuff to fix. Get priorities, get the big things fixed first. Ann, questions and answers?
Yeah, Dave Friedman.
Hello? Oh, Dave Rubin, Clarinet. Yeah, I just want to come back to your point on wildcards. We use them quite successfully, and there are quite a few myths about them not operating with DNSSEC. And to those, I'll really say, if you're still using INSEC, you should really be using INSEC 3.
Yes. Well, for wildcards, the issue with pointers and wildcards is not the DNSSEC problem. It is the fact that since you do it per label, the results are unexpected to most people, and how you have to configure it is confusing. The issue with lying on the fly and DNSSEC is, in that case, you're not really quite wildcarding. I suppose you could also construct wildcards on the fly, though that would also be mildly complicated. The other thing that you have to remember with DNSSEC is, if I do wildcard.foobar.com, I am signing usually that it says 2 labels are signed, which means I've signed foobar.com, but the wildcard is still unsigned. So it actually is something you should not trust. Look at how wildcards are done. If you're truly doing validation and actually caring about that if it doesn't validate, you will not connect to it, wildcards are not useful in DNSSEC, for better or worse.
Okay. I saw another disembodied hand at the back of the room. Is that disembodied hand still raised? Yes, Adrian Kennard.
Yes.
I can't, from where I'm stood, I couldn't actually see Adrian. I could just see a disembodied hand.
I'm not sure if I was the hand you were looking for, but just privacy addresses are driving me nuts. We do use reverse DNS. We generate them on the fly, but we check a database so we can create individual entries and things. And you know, I have my iPad set up, and it comes up iPad whatever. It's great, and it's in logs and so on. And then one day, iOS update meant they do privacy addresses with no way to turn it off. So now my reverse DNSs are broken, and I'm not quite sure what we do about that. You know, devices are meant to let you turn it off, but some don't, and it's annoying.
Yes, and that's another one where the RFCs are somewhat clear, and it is vendor dependent. Having worked at both ISC and Infoblox where we do it that, my standard response is engineers will change features based on people who are paying money screaming at them. And engineering VPs are not allowed to throw resources at problems that no one has screamed at yet. So please, and just like with security and any number of things, I encourage you all to say to your vendors, if it doesn't work in V6, I don't want it. Even if you're not ready to roll out V6, don't buy anything that isn't V6 capable, and people will actually start rolling out stacks that are useful and not broken.
So if in doubt, yell at your vendor, basically, because that seems to be all they understand is yelling.
Yes, and which I know I work for a vendor, but yes, I will tell you first, screaming is indeed what will get their attention, particularly screaming attached to a check or someone who's already paid a large check and is now unhappy.
Yeah. So nothing ever changes there.
No.
Okay. If there are no further questions, then Bev, hold your peace.